So let's do a little bit more review. We're going to go through all the linear algebra that your advisors in the MSFE program tell me you already know. And econ students already know it as well because I've understood you know these things here in econ. Lori Lynn, how do we do vector addition? Okay, so vector addition is done element-wise, which means that the two vectors have to be conformable. What's that mean, conformable? If you're adding together two vectors, then they must be conformable. Yeah, same number of rows in both vectors. All right. How do we do scalar multiplication in the vector algebra? Yeah, each of the elements in X gets multiplied by a scalar, whatever happens to be. Tell me what an inner product is. What's an inner product? You could give me an example if you want. Inner product. Inner product. An inner product. It's trying to do multiplication of two vectors, right? So give me sort of the mechanics of it. You need to tell me about conformability. Suppose you have a vector that's m-dimensional, and you have another vector that's n-dimensional. Can you construct the inner product from those two? You have one vector that is, suppose you have x is m by 1, and you have y is n by 1. Can you construct the inner product for those two? N as in Nathaniel, and M as in Matilda. So we'll make it S and T. Those would make quite distinct sounds. So in order to construct the inner product, what has to be true about S and T? Wait a second. You're Nicole, right? S should be equal to, that's a T. So S has to be the same as T. Okay? And how would, algebraically, how would you write? What would you tell me to write if I wanted to write or represent in symbols the inner product of X and Y, provided that S and T are the same? So if X was a column, we want to turn it into a row by taking its transpose, right? And then post-multiply by Y. And then, right, so that's the inner product.